So for our first example, we want to graph the function f of x equals 3 sine of x. So for step 1, all we want to do is identify our values for a, b, c, and d. Here, we have that our value for a, because we have 3 sines, is 3. Because we just have an x, b is 1. And because we don't have any constants tacked in anywhere, c and d are both equal to 0. From there, we want to take our values here and use them to get our amplitude and period. We don't have any phase shifts to worry about. So our amplitude, A, in absolute value, is 3, while our period, which is 2 pi over b, 2 pi over 1, is just the standard 2 pi. So, to get our quarter periods, we're going to take our value there, our period, 2 pi, and divide by 4 to get that these quarter periods happen every pi over 2, starting from the initial position where, because we don't have any phase shifts, our first point, x1, that we're working from will be 0. And then from there, if we want to get the rest of the points that we have to work with here, we're just going to take that value x1 and add to it our quarter periods until we end up at the end of a period. So we're going to take x1, add to it that quarter period of pi over 2 to get x2, which in that case, pi over 2 plus 0 is just pi over 2. Then to get x3, we're going to do the same thing. x2 plus pi over 2, which is 2 pi over 2s, gets you to pi. Then x4 is x3 plus another pi over 2. Pi plus pi over 2 is 3 pi over 2. And then finally for x5, we're taking 3 pi over 2 and adding to it another pi over 2 to get 2 pi. And those are our values. Those are our 5 key points, as the book here calls them. So once we have our 5 key points, we move on to our next step. We move on to step 3, where we're going to turn those 5 key points into a table of values in terms of them. We're going to take our x values, 0, pi over 2, pi, 3 pi over 2, and 2 pi, and put them into the function that we're working with, y equals 3 sine x, where at 0, we'll get 0. At pi over 2, we'll get 3 sine pi over 2, which is 3 times 1, or 3. At pi, we'll get 0 again. And at 3 pi over 2, we will end up getting negative 3, because sine of 3 pi over 2 is negative 1. Multiplied by 3 gets negative 3. And then finally at 2 pi, we get 0 again. So in total, the coordinates we're working with to make our first period are 0, 0, pi over 2, 3, pi, 0, 3 pi over 2, negative 3, and 2 pi, 0. And if we want to turn that into a graph of a single period, well, what we would do is take those points. We take the values that we have that we're working with and just draw our curve in between them, where there's also a graph of sine in there, just for reference, so we have a cleaner picture, so we have a good little comparison. And that is our 4th step, where, because we want to get a little bit more, we can extend this out a bit wider, another half period to the left, like so, by repeating that downward cone, where we can see the period that repeats every 2 pi, as well as the amplitude, the height from the middle of 3, and the fact that there's no shifts, so it starts around the origin. And this is really all we do when it comes to graphing these functions. We just take our points, plug in some important values that hopefully we've had a little bit of practice with by now, and we repeat as needed to make a picture. Next, we're going to see what happens when we try to do this with some phase shifting.